Good afternoon, distinguished participants. I am grateful to the organizer for providing me the opportunity to speak before you on my experience on lychee nutrition research. You know that lychee is a subtropical evergreen fruit which has highly specific climatic requirements. Almost all the producing countries fall into the two narrow latitude strips of between 17 and 26-degree latitude of southern and northern hemisphere. And one of the most important thing is that for flowering of lychee is that it requires cool temperature of about 17 to 20 degrees centigrade, while temperature about 25 to 35 degrees favors fruit growth and development. So it seems that it is a very exacting in climatic requirements. That's why only few countries can grow lychee, but all countries enjoy lychees. So we have estimated the optimum leaf nutrient contents to predict the yield, but it differs for the optimum growth, right? So it was reported from South Africa, Taiwan, Australia, Hawaii, and India that leaf nitrogen content between 1.5 to 1.8 at flowering or fruit set are generally optimal for lychee production. Our experience is that more than 1.9% leaf nitrogen at the time of before flowering, it may increase vegetative growth instead of flowering. So that you can see it's a very unpredictable. Even if your growth is very good, all of a sudden if the leaf nitrogen content increased, it may not produce flower. It can turn to a vegetative phase. There are other factors also that we need a like dormant like situation before flowering. It is not with cold, but without any stress dormancy. So 2 months before flowering, if there is rainfall, then you may not get any flowering. You will get only vegetative growth. So we examine the different variables that affect the leaf nutrient content in lychee in our several years experiments. And then this paper I am going to present on standardization of leaf nutrient norms for lychee cultivar Bombai, right? So, so plant grow and absorb nutrients from the soil continuously, and base growth is usually associated with a particular internal nutrient concentration. The task of the plant nutrition researcher is to define the range of nutrient concentration associated with the maximum growth. If you look at the soil types where lychee is growing all over the world, it grows in a range of soil from alluvial soil to rocky soil to loams and heavy clays. In China, in many old orchards are growing in alluvial sand close to rivers. In South Africa, Australia, Israel, we see, even in India, we see it grows well in sandy soils. Medium to heavy clay soils, we noticed in China, India, Thailand, Australia, and Madagascar. And it can grow even in calcareous soil with 30% free lime and pH more than 8.5, such as we see in Florida and Israel. Even in Hawaii, it grows successfully in volcanic soil. So optimum leaf nutrient concentration have been established, and calibration between yield and leaf NPK have been calculated. That is for to have an optimum vegetative growth. So suggested time of sampling. Again, the index tissue, we find that it differed in different lychee growing countries. This is just before flowering or during anthesis like that. So in Australia, Menzel et al., they suggested to sample the leaf tissue after panicle emergence, while in South Africa, Cohen and Duplessis they suggested after fruit set. In Taiwan, Wang et al. Suggested during anthesis. In China, it was suggested before flower initiation by Chen, and we suggested after panicle emergence, like in Australia. So that can predict what is going to be the yield in the coming season. So here is the suggested optimum leaf nutrient concentration on dry wet basis in different countries. You can see it varies from country to country because I have already explained that it grows in different types of soil with different varieties and different soil conditions and in different climates. But mostly, if you look at the data, you can find that these results are the nitrogen is below 1.9%, and very little differences in phosphorus, and potassium is almost similar in most countries, those who have calculated this range. So it basically, if you can look at that, it differs from different countries and in different soils and by different researchers. Now we suggested this is the index leaf tissue. That is, the leaf should be horizontal, and it should be the second pair of leaves, first and second pair of leaves. If you randomly collect it from all four sides, and that can give you the ideal picture that is just before the flowering. So this is the panicles has emerged, the flowering is coming out, and we suggested that you should analyze this leaf. Now what we did is that to look at the different variables, we collected the leaf samples from our 35 years old in the research station, our in garden. The variety or cultivar is Bombai. The situation is 23.5° north latitude and 89° east longitude. The soil is sandy loam with pH of the soil 6.4, and you can see the organic carbon, total nitrogen, available P, available K, content of the soil. And we followed the recommended package of practice that we have developed for this variety in this region. The fertilizer dose or the pruning schedule or the pest management and all these schedules. And we studied the different variables. That is, what is the seasonal fluctuation in different months from January to December. Then we studied the type of shoot, whether horizontal shoot should be considered or vertical shoot. Then we started which pair of leaves is the ideal from the shoot tip. And we analyzed from first pair to sixth pair. Then we analyzed the different direction of shoot, how the nutrient content varies. That is from east, west, north, and south, right? Now the result, this is the tree in our research station, and I am pleased to mention here that the late Professor Samuel Gajit and your Moshe Goren, they all visited this garden some 35 years back, that is in 1985. They have also collected some of the varieties, shoots of some of the varieties. I don't know how many of them they can restored in your research station, right? Now the result. So if we look at the seasonal fluctuations, you can see that in case of nitrogen or the phosphorus or the potash and even calcium, magnesium, sulfur, we find that the nutrients is stabilized mostly, or we can get a good impression of the soil, plant health if we sample during August, September. It is not for predicting the flowering. For that, we need to sample in the month of February, right? And so based on that, we find that the highest nitrogen or mostly the highest phosphorus, also the potash, and these your calcium, magnesium, mostly in August and September. So based on that, we find that this is the ideal time for sampling among all the 12 months. Then I look at the different position of the leaf. That's whether horizontal and vertical. So here we find that in general, the N, P, and K and sulfur concentration higher in the leaves collected from the vertical position shoots, and calcium and magnesium in the horizontal shoots. So among the nutrients, it differs whether we should analyze horizontal or vertical. But when we look at the greater mass or populations and analyze all these 4 or 5 variables, then we come in one conclusion, because you cannot estimate everything. Then for position of the leaves, from first pair, second pair, third pair, fourth pair, and sixth, I show you the photographs in the methodology that we collected the second pair for predicting the leaf. Similarly, we go on estimating up to 6th pair of leaves, and we find that the significant variations among the pair of leaves. But N, P, and K decreased as the leaf age. So you can see that first, second, third, fourth pair has a good amount of leaf, but it decreased gradually. So similarly, the case of phosphorus, though not very, variation is not very high. Potassium also, you can see that this is the trends that the older leaves has lates, while calcium, magnesium, and sulfur was found to accumulate in the older leaves much higher than in the younger leaves. So you can see that the mobile elements, they accumulate faster, while the elements that are deposited in the leaves, there you can find their clear picture or vision if you analyze the older leaves from the tip. Now we go on estimating the different direction of the shoot, east, west, north, south, and again we found that NPK projected towards the east side of the shoot has higher, also the calcium and magnesium has the higher concentration than the south side. It is mainly because this sun is coming from the east and is moving to the south. So naturally there are more photosynthetic activity, more carbohydrate accumulation on those side of the leaves, and it shows that. So from this experiment, we can understand that there are many variables if you want to analyze the leaves. First of all, you have to select which pair of leaves, what are the months for vegetative growth and for predicting the yield, and then how you will estimate. Normally, we suggested that from all four sides of the tree, it is better to collect, not only from east, to understand your nutrient needs of the plant, and based on that, we go on fertilizing the tree every year, and also that we should look at that this for get the correct estimation. One-time leaf sample may not be useful for other elements other than NPK. We may need to calculate. We may need to estimate in another time of the year. So based on these experiments, we conclude that to have a good understanding about your nutrient needs of the plant. Again, I am mentioning this is not to predict flower, for which we sample normally in February, because our flowering season is started end of February to first week of March, and so it is better to sample for vegetative growth and to estimate the fertilizer needs. The sampling time should be August, September, and over the several years experimentation and experience, we suggested that the vertical shoots shows the best observations of the nutrient needs of the plant. Then we suggested that first and second pairs from the tip of shoot should be collected from all four directions of the tree for estimation of nitrogen, phosphorus, and potassium, and fifth and sixth pairs for calcium, magnesium, and sulfur to get a good understanding about the nutrient situations of your tree, and based on that we can suggested the fertilizer requirement of that plant. Again, I am telling that this varies from soil to soil, from cultivar to cultivar, but our main commercial variety here in West Bengal or in our research station is that Bombai. So we estimated all variables and we came out with these recommendations. So thank you for your kind attention.